Determine the Laplace transform of f of t is 3t cos ht from first principle. So you know from first principle, the Laplace transform of f of t is given by the integral from 0 to infinity of f of t exponential negative std dt, isn't it? Now there, what is your f of t? F of t, you've been told, is 3t cos 8t exponential negative std dt, isn't it?
Yes.
Are we together?
Yes.
Then from there you know cos is the positive part of the exponential function in Euler's equation, isn't it?
Yes.
So there you are going to have the integral from 0 to infinity of the real part of, we have 3t, so the real part of exponential ja, because cos at, so ja will be 8. Are you seeing that?
Yes.
Because cos was the real part of exponential j8, isn't it?
Yes.
So it is the integral of the real part of 3t exponential j8t times exponential negative st dt. Are we together? So we are looking for the real part of the integral from 0 to infinity of 3t exponential, join them. Now if you join them, you can just now decide maybe to leave t outside without taking the negative side, because we want to integrate on the spot, isn't it? Yeah. So what will you have there? If you are used to leaving negative outside, it is good there. If you remove negative t outside, you remain with s minus j8 into t, isn't it? Yeah. So if you remove negative t outside here, we remain with negative j8, isn't it? Yeah. If we remove negative t, we remain with s alone. See there? Yeah. So you take back your negative, you get your negative st, your positive j8t. Then dt. So integration by parts, it means it is ud dv. Your u is the polynomial 3t. Are you seeing that? Yes. Yeah, so the integral of u dv is uv minus the integral of vd. Senor, integration by parts. The integral of u dv is uv minus the integral of vd vdu. So from there, you start, your u is 3t. U is equals to 3t. So it means du is 3dt. Meaning differentiating u with respect to, you get du over dt to be equals to 3. Then you take dt the other side, isn't it? Are we together? Senior? Yes. Then here you have your dv is exponential negative s minus j8t dt. So for you to get v, meaning you introduce the integral on both sides, so this total derivative goes with the integral, isn't it? You remain with the v. When there's nothing in front of there, you treat it as a total derivative, isn't it? So you remain with the v is equals to, you are integrating an exponential function. If you integrate exponential function, it remains the way it is. Then you divide by that constant of the inner function, which is negative s minus j8. Remember, you are only doing that because you've already identified that the derivative of the inner function is a constant, isn't it? Yes. When the derivative of the inner function is not a constant, you cannot do that. Senor? Yes. Good. Now, having done that, let us come and substitute. So we now have the real part of, in bracket, u dv, integral of u dv, we found it is uv, u times v, this times this, isn't it? So it is 3t exponential negative s minus j8t over negative s minus j8. That is the first part, integral from 0 to infinity, isn't it? See, you substituted that. Yes. U times v, then minus vd minus the integral from 0 to infinity of vdu, isn't it? Yes. What is your v? Your v is this, isn't it? Yes. And your du is this, so it is this times this, isn't it? What will you get? Negative 3 over s minus j8, because this times this, you get negative 3 over this, isn't it? Yes. Then exponential this times dt, you get your exponential negative s minus j8t dt. Now I want people who are observative. If you are observative, you will see the all of that is 0. It is 0 because infinity, when you are substituting the upper limit, when you put infinity here, where t is, you get negative infinity, isn't it? Yes. So negative over a very big number is 0, isn't it? And when you put 0 here, 0 will go to t. 0, t will also take everything to 0. So it is going to be upper limit minus lower limit, 0 minus 0. The whole of that is 0. Have you seen that? Yes. Yeah. Then the other part you are remaining with, ladies and gentlemen, what is it? The other part you are remaining with is? So you have the real part of, this part you are remaining with is what? It's just exponential function alone, meaning it is no longer product rule, isn't it? Yes. So you remove the constant outside, negative into negative is? See, negative in negative is positive. Yeah. Yes. So it is the real part of, we have 3 over s minus j8. Then if you integrate exponential function, you get exponential negative s minus j8. The way it is, then you divide by that constant, which is the derivative within a function, isn't it? So divide by minus s minus j8, isn't it? Then you put your limits from 0 to infinity. Are you seeing that? Yes. So what do we have here? We are now looking for the real part of 3 over 3 times negative is negative 3 over s minus j8 into s minus j8, isn't it? Yes. Then when you substitute infinity, you get 0. When you substitute 0, you get 1. See there? Yes. So it is now 0 minus 1, yeah, which is negative 1, isn't it? So here you have 0 minus 1, negative 1. See, negative 1 will go with this negative. Yes. So you remain with that to be positive. Are you seeing what is happening? Yes. Are we together? Yes. Because when you substitute, this is a constant, you've removed the outside and you multiply with this to get this. So you are only remaining with this where you are substituting, where there's t you put infinity, where there's t you put 0 to put the limits, isn't it? When you put infinity, exponential negative, infinity is 0. Exponential 0 is 1. So it is 0 minus 1, negative 1, isn't it? So negative 1 times your negative 3, which is that you remain with 3. See, we've got rid of the limits. You see, there are some steps which are irrelevant. Meaning, when we do it in the first method, coming the method, second method, we no longer do it because you already see how it is coming about. Have you seen how these things are done? Yeah. So from there, for you now to get to the real part of this, complex conjugate. Have you seen? So the first complex conjugate here is what? Meaning you are multiplying by s minus j plus j8 and s plus j8 because there are 2 of them. For this one, this conjugate is this. For this one, this conjugate is that. See there? Have you seen that? Yes. Yes. Then in the numerator, you have s plus j8 times s plus j8. You see, this one is very complex if you don't have compound ice. That's why shape theorem is the easiest method. See there? Yes. See there? Yes. Yes. That guy knows that. So this one is the real part of 3. Then in the numerator there you have what? S plus j8 squared, isn't it? Yeah. Then in the denominator, this times this, you get your s squared plus 64. Then there are 2 of them squared, isn't it? Yes. Because this times this conjugate, you get s squared plus 64, meaning s squared and in this bracket and negative j squared in this bracket, negative j squared is negative 1 times negative changes the sign to positive, isn't it? Yeah. Or just in the way we say a complex number times its conjugate is just x squared plus y squared. And from here you can see your x is s, your y is 8. That negative and positive here, those are what makes them conjugates, isn't it? Yes. Are we together? Yes. So you see, this times this gives you this times this gives you this again. So it's the same thing squared, isn't it? Yeah. Yeah. So go to the numerator. Go to the numerator. Open that. That is a quadratic identity, isn't it? So we have the real part of 3 into quadratic identity. If you have a plus b squared, see that is a squared plus 2ab plus b squared. See there? Quadratic identity. So it means there you are going to have 3 into s squared plus 2s j8 because it is j8 times your a is s, your b is j8, isn't it? Yes. See there? Yes. So this is now s squared, your a is s. So 2s times 8j, you get what? 16? 16sj, so there. Yes. Then your b squared, b is j8. So j squared is negative, isn't it? Yeah. Then 8 squared is 64. Over, everything is over, s squared plus 64 squared. So the real part, you only collect the real parts. When you take 3 inside, 3 times s squared is 3s squared, 3 times 16 is 48, 3 times 64 is 192. So the real part is part without j. So if you do not the part without j, you are going to remain with 3s squared minus 192 over s squared plus 64 squared. Meaning if you do not this imaginary part, what is left is the real. Because they are sharing the common denominator. And you will find that even integration by parts, you still get the same thing if you don't use the shift theorem. Are you seeing that?
Yes.
Yes. Can you use what you are comfortable with? What I'm trying to say here you have the real part of 3s squared minus 192 does not have j. It forms the real part, isn't it?
Yes.
Then over s squared plus 64 squared. That is the common denominator. Then there we have plus j into 48s over the same denominator, s squared plus 64 squared. So when you are taking the real part is this part only, Senior.
Yes.
Which is 3s squared minus 192 over s squared plus 64 squared. You are done. So which one looks simpler? Is it the shift theorem or integration by parts? The shift theorem, isn't it?
Yes.
Yeah. So I'm not saying the shift theorem is important. It's what look easier. What look easier to use, what you use.